Okay, let's start with a very simple example of rendering to texture where it's going to be very static. We're just going to render a triangle into a texture. Then we're going to use that texture and paste that texture onto a rectangle. So it's about as simple an example as I can do, but the steps are going to be the same as the more complex examples I'll show you in the next couple of lectures. I'll show you one snapshot at the end of a more complex example that we're working on where we do a technique called buffer ping-ponging, where we use a couple of different textures, rendering into one, then using it as a texture, rendering into the other, then using that as a texture, changing everything as we go along. But let's start with a very simple example. And first thing is we're going to look at the shaders, and if we're going to do something, generally we're going to need at least two sets of shaders and therefore two program objects. In this case, which is we'll need these two, one of which will be used for the first render where we render this triangle, so there'll be the normal shaders we'd see with trying to render a triangle in a solid color. And the second sets are going to be different because in that then we're going to be using a texture which we didn't use in the first example, and we apply a texture through the fragment shader. So there'll be two sets of simple shaders and two program objects. Later, our buffer ping-ponging examples will use, I think the ones I'm going to show you will use three sets of shaders, but to use them you just switch between use program object 1, use program object 2, and then back to 1 or back on to 3. Okay, so here are for this example are the simple shaders. This is now, again, we're going to render a triangle, color it solidly as red. So all we're going to do, and I'm going to specify the vertices in clip coordinates, so we don't have to do any transformations here to keep this example focused just on the render to texture. So all we're going to do is change the input positions, send them out in GL position, and the fragment shader simply sets every fragment to be colored red. So they're essentially both of them are one line pass through kind of shaders. Okay. Now, next set of shaders for the program object 2 are going to be to now render to texture. Now, what do I have to render using that texture? And what I'm going to do is render a single rectangle with texture mapping. So what do I have to do? The same things we've done before. If you knew nothing about this, I say, here's a texture. What do the shaders look like? Well, the vertex shader now has to in addition to sending the position out under GL position for each vertex, it also has to send the texture coordinate out. We're going to send that out as a varying variable and as usual, let the rasterizer interpolate the texture coordinates that we will have assigned in the application over the entire face of that triangle. So this is, again, we've seen this before. It's very simple. Now on the output side, where the fragment shader is going to color this exclusively with the color of the texture. So we have a sampler, which is defined as a texture object is normally. In comes the texture coordinates from the rasterizer, and the fragment color is purely the color of the texture. So we have two sets of very simple shaders. Now, the little bit of programming complexity is going to come because we have to set up two renders instead of setting up a single render, and that looks something like this. Okay, so here's the first one. Now, I've left out here all of the stuff about setting up the vertices for two triangles as a rectangle, and the ones for sending over the colors. That's all stuff that you've all seen before many times. So and this program is on the website under I think render 1 for chapter 7. So I'm just going to show you the parts that are a little bit different. So we're going to use program 1. We're going to create a buffer. We're going to send the buffer data over, which is the points array data, which is set up in a simple array. Okay, 0, 1, minus 1, 1, 0. 1, 1, 1, minus 1, so on. So we send it over, we flatten the array as usual. Now we're going to initialize this variable is V position in the in the shader, again, totally standard. And eventually we're going to render that one triangle. Now, I'm going to render it at a very low resolution, 64 by 64, just so that when we do the final render at a higher resolution, you'll see that the texture map has a very low resolution. It's just 64 by 64. And so, you'll be able to tell it's different from the kind of higher resolution renderings we usually do. You're going to set the clear color to be gray so you can see the backgrounds each time. Clear the frame buffer, and then we're going to draw it out as with just 3 vertices, just GL triangles, 3 vertices. So can't be so. So there's the first rendering. Send the data over as usual, render as usual, and a little bit odd here because we set the viewport to be a little smaller than we usually do. Now, what about the second render? Okay, in that case, I'm going to render a rectangle with a texture, with this 64 by 64 texture map. Okay, what does that look like? Well, I'm going to set up first what GLBind frame buffer does with null is that returns you to the default frame buffer, the one that you see on the display. I'm going to disable this vertex attribute. So I want to render with the normal frame buffer. The first rendering I'm not going to see. This one I'm going to see. So I get rid of that frame buffer I set up. I disable the vertex attribute array I was using. Now I'm going to use program 2. I'm going to set the active texture to be texture 0. That's basically the default. I'm going to bind that texture that I just created, and now I'm going to set up the attribute arrays for the texture coordinates and the rectangle as usual. It's going to be 4 vertices for the rectangle, and the texture coordinates will correspond to that. Now here's the data that you need for that second rendering. So this is just returning you to have an active texture and to have the normal frame buffer available to you. Okay, let's see how you now do the setup. Okay, so now I'm going to create a second buffer. I'm going to bind that buffer. I'm going to send over the vertices now for the rectangle, not for the triangle, for the rectangle now. So I'm going to send over 4 vertices. I'm going to send them over as V position for that. And I'm going to enable the attribute array again for V position, and I'm going to send it over to a 2-dimensional standard thing. So again, this is a standard rendering of a rectangle. I send the data over. And now I'm going to send a third buffer over, which is going to have the texture coordinates. So to put it together, the first buffer held the coordinates for the triangle. The second buffer held the coordinates for the rectangle, and the third buffer is going to hold the texture coordinates corresponding to that rectangle. So we send the data over from the texture coordinate array, and then I just send that data over, and then both of these are similar to and same as what we've seen before. Notice here that we're using program 2 instead of program 1. We get the attribute location from program 2. Okay. Now we do the rendering, the normal rendering. So this should be pretty straightforward. So here's we send over the texture object that we created. Again, this is a very normal texture object now. We pick the viewport now is going to be 512 by 512. The clear color is going to be 1. And again, this is so I could show you the contrast between that and the first rendering. And then I clear the standard frame buffer, and then I draw the arrays. Now I have a rectangle. I draw it as 2 triangles, so I'm going to use 6 vertices. That's essentially it. The program on the website is all the stuff I've said in words, but left off of these slides. So what you can see here is the result of the second rendering. Now what is it? It is a 512 by 512 image here. Inside of it, it has excuse me. I cleared this frame buffer. Now inside of it, I have this smaller image, which is the image of the rectangle. Okay, so here's the background that I cleared to blue. Here's the rectangle that I rendered given the coordinates of that rectangle. So it's half the size here. So this is -1, -1. This is -1, -1 down here. This is -0.5, -0.5, which are the vertices of the rectangle. Here, the grayness is the clear color from the first render before I rendered in this red triangle. So this is what I created by render to texture. It's now a rectangle with a texture map on top of it. And you could see the 64 by 64 resolution of that texture map and see it by the jaggedness that you see along the sides of these triangles. So it's as simple as an example that I was able to create. I did an example I have somewhere on my website of saying, well, what if I now combine that with the rotating cube and texture map that on, combining it with the colors on the cube, and you get something like this rotating around. And again, you could see the jaggedness along these edges showing you that this first rendering was really a low resolution rendering of a triangle and put on top of something that already had a color assigned to each face. So again, a very, very simple example of doing that. A little more complex thing, and this is what we're getting to, and it's a lot more code, but it's more, but really in principle, not that much more complex. And so what if we want to make this a little more interesting and have these textures change in time? And this is the heart of being able to do GPU. And the idea is to use what's called buffer ping-ponging. So you put the original data into one texture, and then you render into a second texture. Then you swap these buffers and then re-render, so you can put changes into. Now we'll go into when I did the swap. The texture that I'm using is now going to be texture 2. That texture 1 is no longer needed, but I'm going to use it to render into. And I keep swapping that around to get to see some very dynamic behavior. What I'm going to show you in the next 2 lectures, I think. I'll do another simpler example first. In 2 lectures is how to get a particle simulation or an agent-based modeling simulation out of it, which is very equivalent, it turns out, to trying to solve a partial differential equation numerically with using GPUs instead of using CPUs. And what the example I'll show you does something like this. It starts with randomly moving a particle. Now we can render that particle as a point of any size. That's simple. Now what I'm going to do is diffuse that image to create this kind of blurring effect, and then on the next iteration I'm going to stick in a particle in a new position. The example I'll use is moving it around randomly. Now, so you see sort of what's going on here. The render to texture is allowing me to keep a memory of where this particle is, or in particular, its diffused image. And I can keep bringing it back and bringing it back. So I'm sort of doing 2 things at each iteration. I'm diffusing what I already had a little bit more, plus I'm re-rendering a particle in a new position. So here's one. It turns out it uses 3 program objects, because this is totally artificial example. The one I'm going to show you is maybe a little bit more sensible, but it does show the principle. So here's 2 snapshots from that simulation. So look, there's 2 things going on here. One is that I'm rendering the Sierpinski gasket and then diffusing its results by spreading the color at each fragment out to the surrounding points. We'll show you the shaders to do that in that lecture. Then I keep doing that. So eventually what's going to happen, looking at the background, is that the Sierpinski gasket, the redness is going to be spread out all over the place, and it starts disappearing as it gets diffused around. And it turns out this is the part that's very similar to solving a diffusion partial differential equation. You do exactly the same kinds of calculations. Now the second part of that is I put a black point in here. So this is I think I did this with anti-aliasing, so it's a single point, but it's very large in pixels. I think it's 10 pixels, and the anti-aliasing makes it look kind of roundish. And then I diffuse that image. So now two things are going on. The Sierpinski gasket is being diffused. This particle, this blackness is being diffused. And then I'm moving the particle around in sort of Brownian motion, having it move around randomly. So that's why you need three shaders. You need a shader for diffusing this background, a shader for diffusing this particle, and a shader that then actually just puts the particle out in a normal way each iteration. So here it is, a bunch of iterations in. You can see the particle has moved around, it's been diffused about, it's presently over here, and you can see the blackness spreading out plus the background. I'll show you examples dynamically in those lectures of how we do that. But first, what we're going to do is use render to texture as a method of doing picking, which we said we were going to do. We didn't really so far have a good method of picking. This is an excellent method of selecting objects on the display.